exponent, highest power of 2. Okay, so if we had something like this, y equals, well, let's say 3x squared minus 4x minus 2. At this point, you have a function. Now, you've got to be careful and resist the temptation. At this point, could we solve for a value of x in that particular polynomial? And the answer is no. Because we don't know what it's equal to, do we? There is no value there that is set equal to. People automatically just set stuff equal to 0, but that's an assumption that may or may not be valid. And as often as not in this class, it's not going to work. So make sure that before you start solving this thing that you know what it's equal to. If this was equal to 7, for example, okay, if you're asked to solve this 3x squared minus 4x minus 2 equals 7, how would you go about the process of solving for values of x that make that true? Well, what's the easiest thing to solve? Yes, sir. That's it. Yeah, you move the 7 over and get the thing equal to 0. Ultimately, you want it equal to 0, which is why folks are always setting them equal to 0 right off. And we'll talk about why 0 here in a little bit. What's so special about 0 and what's more difficult about solving it equal to 7. But what you could do is subtract 7 from each side. And you have the 3x squared minus 4x minus 9 equals 0. Does that make sense? Okay, let's say that we just go ahead and you're told that this needs to be 0. And what this is saying is that the y value needs to be 0. If the y value is 0, graph-wise, where are we on the graph? If the y value is 0, where are we located on that graph? Not a specific point, but you can tell about where we are. We're going to be, let's see, if the y value is 0, are we above the x-axis, below the x-axis, or on the x-axis? Well, if the y value is 0, can we be up any? If the y value is 0, can we be down any? So if the y value is 0, that means we are looking for values that are on the x-axis. Does that make sense? So the purpose of setting a function equal to 0 is to find where does that function intersect the x-axis. In business and things like that, it's going to have specific meanings. Okay? For example, if this is a quantity we're going to be producing, and this is the price, okay? Finding where it intersects the x-axis would mean the price is what? 0. Suppose instead of price that was profit. That would be where the profit is what? 0. And where the profit is 0 is the break-even point, if you'll recall. Does that make sense to everybody? We're all semester, all year long, going to be talking about, okay, so we've got x equals whatever. What does that really mean? And that is very, very important for you to be able to get to on each problem. All right, there are several ways to solve this thing. What's one way to solve 3x squared minus 4x minus 2 equals 0? There are a bunch of ways. What's one of them? Suppose your whole course grade wrote on you in the next 5 minutes solving that equation equal to 0. Find the x values where it equals 0. What is the maximum number of solutions this equation can have? 2, because the highest degree is 2. Remember, if it's a degree 5, the highest power is 5. The most answers you can have is 5. If it's degree 2, the most answers you can have is 2. Might have 0 and it might have 1. Might be a double root. If the polynomial goes like this, okay, how many solutions will it have? Now remember, we want to know where is the y value equal to 0, don't we? On that particular graph, where's y equal 0? It doesn't, does it? So how many solutions would that have? None. Is it okay to say there are no solutions? This year it is, and from this year forward the rest of your life, it's okay to say there are no solutions. Design a car that'll carry 15 people, plus all their luggage, have a top speed of 150 miles an hour, and use 2 drops of gasoline per hour at 150 miles an hour. Based on technology available now, is there any solution to that problem? Not really. Okay? So it is possible to have situations where there is no solution. And if there's no solution, what do you say? I'll get right back with you. Give me a week and I'll have that car ready. You better not be saying that. Instead, you say, there is no solution. And then go ahead and explain why. Okay, one way to solve this is with the quadratic formula. Now, remember, you can only use the quadratic formula on quadratic equations. People try and use this on cubics and all kinds of stuff. It only works on quadratic equations. That's why it's the quadratic formula. Just in case you've forgotten it, it's going to be not x. It's going to be y equals, wait a minute, it is going to be x. What am I thinking here? Okay, I'm looking forward to getting you to Wolfram alpha. Negative b plus or minus the square root b squared minus 4ac over 2a. Does that look familiar? Seen that before? Oh yeah, didn't know I was ever going to have to use it. Yeah, keep that in mind. You're going to be using it routinely this year. If you go down to the math lab, take your calculator and say, would you please put the quadratic formula into my calculator? If you go down third row, third button over, see where it says PRGM? That means programs. Okay? Odds are right now you press program, there's nothing there. It's just blank screen. Well, not blank screen, it's got the little toolbar across the top. Some of you may have something that says something like quad 83 or quad form or something like that. If you happen to have that, you select that particular program, you move the cursor down so that's highlighted, you press enter, and it'll come back and it'll say a question mark. What value would you put in from this particular equation in the upper right hand corner? What would you put in for a value of a? 3. Then when you press enter, it'll come back with a prompt b. Now be careful, what's b? Negative 4, very good. Remember the negative, and the thing that people mess up most often, over on the right hand side, see the gray key that says subtract? That is not negative, that is subtract. If you press this key and 4, the program's going to blow up. What you want to press instead, where's the negative sign on these calculators? On the bottom, yeah. The negative sign's on the bottom. Be careful, they mean two very different things. You'll get your negative 4, press enter, and then obviously for C, you'll put in the negative 2. Okay? Does anybody have quadratic formula on their calculator? No, not so much. Very good. All right, so what happens is we're going to wind up with x equals the negative of b, so that's going to be a negative 4, plus or minus the square root of negative 4 squared minus 4 times a times c all over 2 times a. That's partial credit. Show your work. There are some people who are just getting answers. And you'll notice if you just get answers, how much credit do you get if that answer wasn't what we were looking for? Not much. Show your work. I'm not asking you to show your work because I love grading partial credit. I'm asking you to show your work because got the right answer. Yeah, well, at the top of the grade or the quiz or the test, it'll always say you must show your work to get how much credit? Any credit. Okay? Oh, man. Okay. So, for this one, please don't try and tell me that you're doing the quadratic formula in your head. I'll say, pretty cool. And I'll slap one up there and say, show it to me now. I want to see that trick. Okay? It can be done. I'm not saying it's impossible. Just say, wow, that's pretty cool. 4 plus or minus, this is going to be a square root of 16 plus 24 over 6. Does that make sense to everybody? Which is really going to be 4 plus or minus. Now, inside of the square root, that's going to add up to 40, isn't it? The 4 can come out. What's the square root of 4? 2. So it's going to come out as 2 square root of 10 over 6. This can be rewritten as 2 times 2 plus or minus the square root of 10. The whole thing over, I'm going to factor out the 6. 6 is 2 times 3. Does that make sense, what I just did? The 2 in the numerator is multiplied times everything in the numerator, isn't it? The 2 in the denominator is multiplied times everything in the denominator. What can happen to those 2's? They will cancel. Which really means that our solution is going to be 2 plus or minus the square root of 10 over 3. And notice that truly is how many solutions? There are 2 of them there, aren't there? There's one where it's 2 plus the square root of 10, and a second option where it's 2 minus the square root of 10. It is possible with a quadratic formula that you get no solution. Okay. How could you get no solution? Yeah. Good. Yeah. Now you whipped out a big fancy word there that I was really impressed with. What on earth is a discriminant? That's right. If this part inside works out to be negative, you put down that there's no solution. And you also put down there is no solution because the discriminant is negative. Now, there are solutions, but they're not in the real numbers. They're in the complex numbers, aren't they? Okay? But as far as the real numbers go, which is where we're going to live this year, no solutions. All right, one way to solve this is quadratic formula. Okay, so you're on a quiz, you're on a test, whatever, and you're thinking, I don't have a whole lot of time. The second way to solve this is graphically. So you might be thinking, I don't have a whole lot of time and I really don't trust my quadratic formula skills. The second way to solve this is in your calculator. Does everybody know how to graph that on your calculator? Okay. In your calculator, you just, for y1, plug in, let's see, it says 3x squared minus 4x minus 2, and you graph it. When you graph it, you're going to get some kind of a graph that goes like that. Depends on the window as to exactly what it looks like, but it's definitely going to drop below the x-axis as well as being above the x-axis. Are you okay with computing zeros? Is everybody okay with that? Okay. I'm not seeing anybody raise their hand, so if you're just uncomfortable saying, yeah, I don't get it, hit the math lab. Know how to do that by Friday, because you're going to need it for the rest of the year. That doesn't just mean 2019, that means up through May 2020. A third way to do this, and this route won't be an option on most quizzes and tests, but it's a route that I want you to be aware of, because out in the real world, when you're working at P&G or Kroger or wherever you're going to get a job, they're not going to say, solve this, and you're not allowed to use the computer. Are they? They don't care if you use the computer. There is a program called wolframalpha.com. Okay? It's a nice piece of software. It's free. You can look up all kinds of stuff on it. It's a search engine of sorts. It does computations as well as, it'll look up stuff for you from chemistry, from physics. If you want to know the population of Cincinnati in 1830, you can type in population of Cincinnati 1830 and it'll get it back for you. One of the things that's nice about this piece of software is that you do not have to have a specific order or specific code to get it to work. You just type in what you want it to do. Solve, let's see, we've got a 3x squared, subtract, what was it, 4x minus 2 equal to 0 for x. Okay, we just want to solve for x. Press enter. Okay. Now, when it comes back, be sure that you check what it has interpreted the input to be. See right there where it says input interpretation? Make sure that it's thinking the same thing that you're thinking, because it'll give you back an answer. But if it's to a different question, what good is it? Okay. What's the temperature out? I've got blue eyes. And the answers are going to be just that bizarre if the input interpretation doesn't match what you actually wanted to solve. But if you then take a look, if you can see this very well, but do you see down there at the bottom? It's got the two answers we came up with, doesn't it? Okay. So Wolfram Alpha, it's free. There are versions of it that if you want to subscribe, you can. I'm not telling you to subscribe, but there are versions that you can subscribe to, and if you subscribe, it'll give you step-by-step solutions to any problem you put in there. As in anything we do this year, any calculus problem, you shove it in there and it'll give you the answer back step by step by step. But you got to subscribe. I forget what it is, like $4 a month or something like that. Okay. Actually, the guy that developed this is kind of interesting sort. Okay. I don't know if you've ever heard of a program called Mathematica. Okay. It's kind of the standard for use around the world as far as amongst engineers and scientists and stuff who are really doing some serious number crunching stuff. It was developed by this guy and some folks he hired. Okay, serious piece of software. This guy's actually pretty bright. His name is Steve Wolfram. He finished his PhD in particle physics. Not started, finished his PhD before he was 20. Go get him. You've got a few months left. Okay. That's kind of amazing. Okay, so the boy is pretty bright, and he went into this area. There you go. Make sense? Everybody good with that? It's there. Do you know how to get to it? You just type in wolframalpha.com. Okay. All right. So a third way to solve this is with Wolfram Alpha. Traditionally, the way you abbreviate Wolfram Alpha is the W/A, and the slash truly is a vertical line, not supposed to be a forward slash or anything like that. It truly is a vertical line. So a couple ways. Great. Everybody have a chance to sign the attendance sheet for today? Everybody's good? Super. Okay. All right, so that's how you go about solving various quadratic functions. Everybody good? You can get 0 solutions, 1 solution, 2. Well, how could you get 1 solution to a quadratic formula? If the quadratic had a graph like this where it intersected only at x equals 3, that would give you 1 solution. Well, gosh, how could you get something like that? Well, that means that x minus 3 would be a factor, doesn't it? And the other factor would also be x minus 3. And you can FOIL that out, and ta-da, you've got it. X squared minus 6x plus 9. It's a double root. It gets that answer twice. Now, while we're here, I want to quick point out something to you. Oftentimes, with the functions that you get, or have seen up to this point, they'll factor nicely. What is an advantage to solving these things equal to 0 as opposed to equal to 10? I don't know. They always just told me, set it equal to 0 and solve. Ooh, does that sound familiar? Set equal to 0 and solve. Why 0? Well, it's easy to write. No. There's a much different reason why 0. Let's play a game. I'm thinking of two numbers. You multiply them together and you get 10. What are the two numbers? 2 and 5? Well, yeah, those do multiply to 10, but they aren't the ones I was thinking of. Okay. Right answer, but not the same answer as I had in mind. Are there two other numbers that can multiply together to give you 10? Yes, sir. 1 and 10. That does multiply to give you 10, but wasn't what I was thinking of. Two numbers that multiply together to give... Are you starting to think that this game is rigged? And all you can do is get... Yeah, they do multiply to 10, but it wasn't... You want to know truthfully what I was thinking of? I was thinking of 10 over pi and pi. Do those multiply together to give you 10? Yeah. Oh my gosh, how many different possible answers are there to multiply to get to 10? Well, at least 3. Do you buy that there are an infinite number of different options? Okay. There are an infinite number of number pairs that will multiply to give you 10. If, however, we know it's equal to 0, I'm thinking of two numbers, they multiply to give me 0. What does one of the numbers have to be? Has to be 0, doesn't it? Things are narrowed down then. Okay? One of them's got to be 0. No ifs, ands, or buts about it. The reason for solving equal to 0 is you know what one of the numbers has to be. If one of them has to be 0, that means this x minus 4 has to be 0, or the x plus 3 has to be 0. Do you buy that? Now you can figure out some answers. One possibility is x equals 4. Another possibility is x equals negative 3. That's why you solve things set equal to 0 and not 10, 1, or anything else. Well, nobody ever told me that before. Yeah, they may not have known themselves other than set equal to 0 and solve. Okay? Not saying anything bad about them, just saying they may not have known themselves. All right, quadratics are a friendly set of functions to deal with. They either have 0, 1, or 2 solutions. You can go after it by solving for a solution on your calculator. I mentioned earlier that one way to get solutions is graphically. If you're on a quiz or a test and you've got about 45 seconds left, oh crud, I got to get it fast. And the quadratic formula, yeah, I keep meaning to get that on my calculator. I got to go to the math lab someday, but obviously this isn't the time. What's a fast way to get that done? Put in the y1 equals, graph that puppy, get the zeros. You should be able to get it pretty quickly that way. And it'll be the same answers as plugging it into the quadratic formula. The only thing you need to be aware of is if you have something like this, no solutions. You just write down no solutions, and you point at this and say, see, it does not intersect the x-axis any place. Make sense? All right, let's move on. Polynomials. So we've talked about quadratics. Quadratics are a specific type of polynomial function. There are polynomial functions where the degree is 2. Well, that's not the only degree to a polynomial, is it? You can get all kinds of stuff. In general, a polynomial winds up looking like, you're going to get something like y equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 plus dot 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 plus a sub 1 x plus a sub 0, where n is an element of the integers that are greater than or equal to 0. So that's things like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way out to positive infinity. What on earth does that notation mean? Well, each of the a values is a coefficient. Could be positive, could be negative. Each of them has their own subscript, doesn't it? Like a sub n minus 1. That means they're each a different value. A couple of them could be 3. That would be fine. But they each have the option of having their own value. The other thing that's important to notice on this is that this matches this. So what we could do is we could write something like a sub 5 x to the 5th plus a sub 1 less x to the 4th, 2 less x cubed plus, now a sub 1 x, if the subscript and the exponent are supposed to match, what exponent should be on the x? Should be a 1, shouldn't it? What is there? If there's not an exponent there, it's understood to be 1. Plus, now here's something sneaky, a sub 0, this really should be x to the 0, but we didn't write the x to the 0 there, did we? Why not? What's x to the 0 always going to equal? 1. And 1 is just assumed to be there. So we could do a sub 0 x to the 0 or a sub 0 times 1, but we're just assuming it's there. Okay. Does that make sense how this notation works? Do these coefficients have to be integers, or could they be fractions and stuff like that? They can be fractions and all kinds of stuff, can't they? Okay, so this could be 2/3 x to the 5th minus the square root of 7 x to the 4th plus pi over 9 x cubed, and you get the idea. It could be a mix and match of all kinds of stuff. Typically, it will be the regular old integers or just some nice fractions for a while. When we get to R7 and we're doing modeling, trying to get a function that fits a set of data, then you can get all kinds of weird stuff. Like you can get coefficients of 0.0037. Was that right? Yeah. It's okay. Okay. Make sense to everybody? In addition to polynomial functions, you can run into rational functions. If it feels like we're going fast, we are kind of moving along, but it's not as bad as what my daughter got hit with. Okay? She's taking the engineering path, and last week on the first day of school, she walked in, and they said, "Hi, welcome to Chem 1. Chapters 1 to 12 you should know. Study those and have them done by Friday. We're starting at chapter 13," and off they went. So at least I didn't jump into the 13th chapter and say, "Get the first 12 chapters done by Friday." Okay, and she came home, "Dad!" Okay, rational functions. Anybody know what those are? They're fractions, aren't they? They look like things like, and I'll just make up a couple here. Things like y equals x plus 7 over x minus 3. Now you have to be careful on the domain of this function. Oh, wait a minute, what's domain mean? The domain is the x values you're allowed to use. Now, instead of listing all the x values you're allowed to use, it's a whole lot easier to just say the things you're not allowed to do. You're not allowed to use what? 3. So the domain here would be equal to, and there are a couple ways to write this, a set of x such that x is not equal to 3 and x is an element of the real numbers. So there's one way to write it. The domain here could also be, let's see, from negative infinity to 3, along with 3 to infinity. That says the same thing, doesn't it? Okay. It could also be negative infinity is less than x is less than 3, along with 3 is less than x is less than infinity. So there are a variety of ways of listing the domain. But with a rational function, the only thing you need to be careful of, or the primary thing you need to be aware of, is the denominator can't be 0. Can't be 0. We talked about that the other day. Okay? So the domain is going to be limited to values that keep the denominator non-zero. Does that make sense to everybody? One of the things that you need to be aware of is there are all kinds of functions out there. Yeah, I know. Okay? And with some of them, a subset of them, it's really handy to have a basic idea of what the graph looks like. Okay? Let's take a look at some basic functions that we're going to be running into all year long. And it's kind of handy to know what the graph of these look like. Okay? So let's take a look at some basic functions. I'm guessing that you ran into this somewhere along the lines of a college algebra class somewhere, either in high school or here, or somewhere. Let's say if something like y equals c, where c is an element of the real numbers. An example of this would be something like y equals 5. Is that really a function? Well, if we graph it, what that means is regardless what the x value is, the y value is always going to be 5, and the graph is going to look like this. Does that pass the vertical line test? Sure does. It's a function. Okay. A second real common one is going to be y equals x. Example, y equals x, and it's going to be, what's the shape of this graph going to be? Just a straight line, isn't it? What's the slope of the line? 1. So it's going to go up at a 45-degree angle. And there it is. Third one. We've talked about this one a little bit. Y equals x squared. Y equals x squared is going to be a parabola, vertex at 0, 0. Okay. Didn't pick up all the way. There we go. A fourth one is going to be y equals x cubed. Oh no, what's he going to do? Go all the way to infinity, one power at a time? Okay. Y equals x cubed looks more like this. And it makes some sense. It's basically going to look like a parabola, a little bit steeper on the climb, and a little bit steeper on the decline. Why does the left leg of this thing drop down instead of going back up? Well, if you cube a negative value, what do you get back? Positive or negative? Negative. That's why the left leg drops down. It doesn't go up like the quadratic does. Okay? Another basic one. It's going to be y equals the square root of x. Square root, well, first off, this has a domain that is somewhat restrictive. What are the values of x that you are allowed to use? Positives? Right. Are we allowed to take the square root of 0? And this is one that I'd look back and some are going like this and some are going like this. What times itself equals 0? 0. Oh, so the square root of 0 is 0, so 0 actually works. The graph of square root starts at 0 and it goes like that. This is what the graph of square root of x looks like. Okay. 6, y equals the absolute value of x is going to look like this. Those should be straight lines at a 45-degree angle. And a last common one that we're going to include in this list is going to be y equals 1 over x. What is the domain of this function? Or is it anything we want to use? Yeah. Just can't be 0, can it? Anything but 0. When you graph this, the graph goes like this. The graph is asymptotic to both the x and the y axis. Okay? I know I flew through those. Okay, I understand that. I know I'm kind of flying. I'm thinking this should be review stuff. And I'm thinking at least I didn't say 12 chapters, go do the first 12 chapters on your own. Okay. Let's take a look at an example of how to graph something like one of these. Let's say we have something like y equals a negative 1/3 the square root of x minus 4 plus 6. One way to graph this would be to plug it into your calculator. A second way to graph this by hand is to go through a series of steps. I'm hoping you've seen these transformations before. Okay. The way I usually teach it is start out with your basic function, y equals square root of x, which gives you a basic shape to the graph, doesn't it? The basic shape is this. Second thing, work with what's going on inside of the function, the inside part, x minus 4. If it's a minus, it shifts the graph to the right. If it's a positive, like it would have been x plus 4, it shifts it to the left. Well, why does it do this shifting stuff? Well, because what we're looking for is where do we get a y value of 0? What x value do you have to plug in to get 0 back? Well, you have to plug in x equals what to get 0? 4, positive 4. So what's happened is the x value now has moved to positive 4, and the effect that that has on the graph is to move it over 4 units. Does that make sense to everybody? Reasonably, what's going on? Okay. Next thing. You can go either of two directions. I'm going to do the negative 1/3 square root of x minus 4. Do you see how I'm just throwing in one thing at a time? Okay. Not trying trying to multitask and do 4 separate operations at once. Okay. We know that our vertex is at 4, 0. If we take every number that comes out and multiply it by a negative, now every number that comes out is going to have a negative value attached with it, isn't it? If you look at the previous graph, everything coming out here was a positive y value, wasn't it? Everything was a positive y value. However, now that we have put that negative in front of the coefficient, all the y values are going to be what now? Negative, aren't they? So instead of the graph going up, the graph's going to do what? Go down. And what's the 1/3 going to do? Is it make it go down faster or slower? Slower. It's going to go down at 1/3 the speed. So for example, if you would have had -1, now you have a -1/3. If you would have had -3, now you have -1. If you would have had -9, now you have -3. Do you see it's slowing things down? So what happens is it's still coming over to 4 to start, but the y values aren't getting negative as fast. Sorry, kind of squiggly there. Have a hard place to draw. Oops, gravity strikes. One last thing to do. See the +6? We have y equals a -1/3 square root x minus 4 plus 6. What's the +6 going to do to every single value on that graph? Go move it up 6, isn't it? So you grab the whole graph and you move it up 6 units. We're still going to come over 4. 1, 2, 3, 4, but we're going to go up 6. 1, 2, 3, 4, 5, 6. There's our start point. And the graph's still going to have the same basic shape to it. And there it is. Does that make sense? Now, the cool thing is, once you get used to going through these, and it takes a little bit of practice, let's say I have 3 times the absolute value of x plus 2 minus 5. Gosh, wonder what the graph of that looks like. Once you get the hang of it, you know what the basic shape is, right? What's the basic shape of absolute value? It's a V, isn't it? See that +2? What's that going to do to the V? Move it to the left 2 units. And the -5 is going to do what? Move it down 5 units, right? Okay, so we're going to go to the left 2 units. 1, 2. We're going to go down 5. 1, 2, 3, 4, 5. Is it going to open up or down? Up, because it's multiplied by a positive. When we multiply by 3, will the y values get big faster or more slowly than they would have before? Faster. So instead of it being at a 45-degree angle, the lines are going to be steeper. Boom, boom, and there you go. It'll get to the point with a little bit of practice, you can look at these basic things and graph it within 3 to 4 seconds, which is way faster than you could ever hope to do on your calculator. It gives you a general shape, a general idea of what's going on. Does that make sense? Everybody okay with that? All right. One last thing I want to hit upon here before we finish out, and it will finish out 6-5, or R, whatever we are, R5, yeah. We're moving up to chapter 6 now. It's only half as bad as chemistry. Okay? When you encounter things like y equals x to the 3/7 power, you need to be able to rewrite this as a radical. And people are, uh-oh, I forget. Is this a cube root or a 7th root? 7th. Really stupid. But if you forget, where's the root? Look outside. Where are the roots? Are they above or below ground? They're below ground. So where are roots? They are below. So the root is the 7th. So it's going to be the 7th root of x cubed. Does that look familiar? More importantly, you're going to need to be able to take things like this, 2 cube root of x to the 8th, and rewrite that as an exponent. Well, why? Because when we start doing derivatives and stuff, you're going to need that to be something like x to the 3/7, so you can compute the derivative. You're going to need x to the 3/7 so that you can do the integral. Well, I don't know what derivatives and integrals are, but that's what we're going to be doing all year long. So you can't do anything for the rest of the year unless you can rewrite that as x to some power. The rest of the year is done until you can do that, literally. That means up through May, not up through December. Okay, so we know we have a coefficient of 2. We're going to have an x. What is the root? What's the root on the x here? It's cube root, isn't it? See it? Aha. Yeah, and you all know where roots go. They go underneath. It's a cube root. And what power is it being raised to? The 8th power. And because it's in the denominator, how do you tell everybody that that x should really be in the denominator? Negative. There are some of these in the homework assignment. If you need to practice more of them, look in the book. Okay? And I know some folks like digital, they can work with that, that's great. Some folks like hard copy. Hit the library, got them on reserve.